Hello everyone. I would like to demonstrate something more on the relative volume ratios for various octahedrons. Here we start with the small cube. This is a one frequency cube, of course, and it contains an octahedron in it. This octahedron is 2/3 of this cube volume. Contains 4 modules, cube contains 6 modules. We have parallel plates here. We have 7 parallel plates, all derived from a single cube using the same modules. This is like a square base stretch cube and has an octahedron in it, like that. So that's 2. This is the other kind of 6 blocks, and it has an octahedron in it. This is the third kind. It's like a ortho scheme. Has 90 degrees in here, and it also has an octahedron in it. Then we have this kind. This is, I think, the 5th one. Has an octahedron in it. I hope everybody can see it clearly. Then we have this one. It also has an octahedron in it. I want to say that there is only 3 kind of octahedrons shared with this cube, and there is the most extreme case derived from a cube. It's the maximum stretch. It also has an octahedron in it. Now these octahedrons, like I said, there is only 3 kind. These are shared with all these cubes, and the relative ratio is always 2/3 in these cases, in all these cases. Some of these are depicted in a crystal lattice structure. This is very fundamental. Like there is only 5 platonics, there is only 7 possible parallel plates derived from a single cube at the lowest common denominator. This is the limit case, but always with the same consistent result. The octahedron is 2/3 of the hexahedron volume. There is 6 blocks in here. The octahedron contains 4. Now here we have a regular rhombi. This one is different because this one contains 2 cube volume. All these I showed just a second ago are 1 cube. This is a 2 cube volume, has an octahedron in it. So this is also 2/3 of the volume in here. So you see the ratio still remains the same. 12 modules and 8 for a hexahedron, 12 modules, and 8 of those are octahedrons. Now here we have a 1 frequency cuboid, and this one contains also 2 cubes just like this one, and has an octahedron in it, like that. So again there is 8 blocks in here. This is an irregular octahedron. 8 blocks in here, and there is 12 blocks all total. Now I can rearrange it like this, and we have a rhombic dodecahedron face. This is a cube's edge. This short diagonal and this long diagonal is a cube face diagonal. Okay. We are back to our cuboid. So this cuboid can have, here is another version of that same thing, and I just want to remove this octahedron. We see the hollowed out part, that the half octahedron fits in here and the other half fits in here, and that would be top and bottom center. The vertices of this octahedron would be here and the bottom, and these 4 corners would be shared at these points. So this one now contains 4 cube volumes, so there is 24 modules altogether, and 8 of those are regular octahedron in it. So now the ratio here is 1/3 of the octahedron, and that's going to be always like that because this is the lowest common denominator. Now here we have a 2-frequency cube, as we said those were 1-frequency cube, and here we have a oblate octahedron, and this oblate octahedron is placed in this cube like that. It's also top and bottom centered. Top is here, vertex, and these 4 are shared at the corners of this 2-frequency cube. So this regular tetrahedron, this oblate octahedron has the same number of modules as regular tetrahedron, as this regular tetrahedron, 16 modules and 16 modules. That means that this oblate octahedron is 1/3 of this cube, 2-frequency cube volume. So this is because the first appearance of the oblate octahedron only exists in a 2-frequency cube. A cube equals 48 modules, this one equals 16. Same as the regular tetrahedron. Now please also notice that this is not a coupler anymore. In synergetics, a coupler couples 2 cubes. A coupler apparently was never envisioned as a top and bottom centered cubic. In synergetics, there are tons of examples to realize how poor, restricted, and limited the synergetics modeling is. Most of the fundamental structures are missing from the concentric hierarchy. Most cannot even be modeled at this level. A 2-frequency cube, which is this one again, has a regular octahedron in it, and this is called face-centered cubic because every face of this 2-frequency cube has a vertex of this octahedron on it. So both the top and bottom centered and a face-centered cubic only exists in a 2-frequency cube as we see it. It cannot be done any other way around. A 2-frequency tetrahedron, which is this one, makes small cube. So now we're going to have a 2-frequency tetrahedron in here and build with the quarter regular tetrahedron just like in synergetics, and we're gonna put them like this just like in synergetics. You see a regular tetrahedron. This is the same tetrahedron as this one. I just want to make sure that we all understand. So now this one contains a 1/8 octahedron in here, as we can see it, they're in here. 1/8 octahedron. 1/8 tetrahedron, I mean. So this cannot be 1 frequency as synergetics labeled, it's 2 frequency, and it also contains a regular, it also contains a regular octahedron in it, same as this one. Same octahedron. So this was never envisioned in synergetic. So half the volume, so this must be 2 frequency because every tetrahedron like this has the half the volume is a regular octahedron in it. Apparently never seen in synergetics. This octahedron, now, that's for the tetrahedron. So not only that we make a tetrahedron from this 2 frequency tetrahedron, but there is an inner octahedron. Apparently nobody knew about it. Now here we have a octahedron. This is a 2 frequency octahedron because this is a 1 frequency octahedron. Well, this is just a half octahedron. This 2 frequency octahedron contains 8 octahedron volume. That's impossible for it to be labeled 1/2. Both of these octahedrons and these regular tetrahedrons out of same frequency, they share the same phases, but it ain't one frequency. They both have two frequency by the virtue of these blocks. Please watch the follow-up to this topic and keep